speaker of the session is Dan Hu. Please, stage is yours.
Hello. Okay. Hello, everyone. My name is Dan Hu. I'm postdoc working at the Masaryk University here, and my primary work focused on the galaxy cluster and the groups. And when we looking for the large-scale diffuse radio emission within this group, we found this very interesting spiral galaxy. Among the 5 main member galaxies, the HCG 97b is the only spiral galaxy with a very distinct radio tail. So we want to know the origin of the radio tail. And let's look at the galaxy itself, if it has the very powerful central agent. And from the X-ray image, we detect the 2 X-ray point-like sources, which are off nuclear. And with the X-ray luminosity, it suggests that there could be the ultraluminous X-ray sources. And one of them, X2, which could be potential an Indian mass. I'm so sorry. Indian intermediate mass black hole. So, but also, of course, it's depending on what kind of accretion mode you assumed. Looking at the radio emission, the radio observation from the VLA gigahertz and the low-fare 144 megahertz revealed that there is an extended X-ray radio emission along the disk, and also a extraplanar radio tail, which towards to the X-ray group center. And you also can find that there's X-ray plume from the group center points in the direction of the spiral galaxy, which suggests a possible interaction between the spiral galaxy and the group center. We also check the ALMA data. For the ALMA high-resolution data, you can see the morphology of the CO emission is asymmetric, and at the southeast side, the CO emission is more intense and slightly offset from the major axis. And if you look at the 7-meter low-resolution data based on the intensity map and the velocity map, we can derive the position velocity diagram. And from this diagram, we also can see that the northwest side is undisturbed, but for the southeast side, if you mirror the counter the right counters to the left side, you will see there is a velocity spark at the radius of 18 arcsecond, which suggests a recent perturbation in the outer southeast disk, which is the typical phenomena for the ram pressure stripping galaxies. Of course, we don't see any distortion or tidal tail of the galaxy itself, but it still can be affected by the gravitational interaction. So we did a very basic calculation to estimate the capability of the ram pressure and also the gravitational interaction. And I won't go into details now, but for the conclusion, we think both gravitational interaction and the ram pressure play roles in the gas stripping, and the gravitational interaction possibly flatten the galaxy potential wear and enhancing the ram pressure efficiency. And do you think there's only ram pressure and the tidal interaction play roles on this galaxy? It seems no. If you look at the relation of the phi infrared luminosity and the radioluminosity, you can find our target has a much higher radioluminosity compared to the ram pressure stripped galaxies and also the normal star-forming galaxy. So it suggests that we might have another mechanism enhancing the radio emission. The radio spectrum gives us some hints about that. The flux density derived from the VLA and the low-fire observation from the curved radio spectrum. When we fit this curved radio spectrum, we find an injection spectral index, which is around 0, minor 0.6, which is the typical value of the AGN jets. So it indicates at the tail, it exists a fresh injected plasma. And if you look at the location of the ultraluminous X-ray sources, you can find the X2, which might have some contribution. So we think the fresh injected plasma might be potentially linked to the ultraluminous X-ray sources feedback, or you also can see the intermediate mass black hole activity. For the conclusion, we think that the formation of the ramp pressure strip, the radio tail, could be also influenced by the gravitational interaction and also the ULX feedback. And it is important to know more about this galaxy and also the associated phenomena. So fortunately, we got some use time this year to observe the galaxy itself and also the potential tail region. Hope that this observation can provide more insights. That's all. Thank you.
Okay, do we have, already, I don't even have to ask.
Hi, very interesting results. Maybe it's more a comment than a question, because I looked actually at some clusters at galaxies which could have ramp pressure, and we also find signs of AGN. So we thought the AGN and ramp pressure can have a synergy to produce such things, and there's also some theoretical papers. So I think it's very interesting if you find also with Muse observations then that this is really happening.
Yes, yes. It's combined their outer interaction and also their the inner side, their interaction.
We have one more there.
On the ULX, do you have the data photometric or to see whether there are perhaps star clusters there? So are these ULXs in these potential IMBAs inside some kind of stellar overdensities or in some specific regions?
We don't. For the X-ray, we don't have such a high quality to constrain more. But for other data, I haven't checked that.
Yeah, because it would be really interesting to see if this is perhaps correlated with a global cluster or a dense stellar cluster.
Yes, yes.
Thank you.
Yeah, thank you.
Okay. Maybe we can take other questions to the coffee break. So let's thank all our today's speakers again. And if I may say, staying on time is also being professional, so just keep that in mind.